Lesson 4.4 is about finding the constant rate of change when you're given a table of tools. So to find the constant rate of change is very similar to what we did in the last lesson. And so what we're going to do is, first of all, we got to find how much this changes compared to how much this changes. And to figure out how much we changed in this column to this column, we subtract it just like we did last time. So we got a 140 minus 70. And our same rule applies. We're going to subtract, again, if we subtracted the bottom one from, if we subtracted the top one from the bottom one, we have to do the same. So we want 140 minus 70, so we're going to have to go 10 minus 5 to find its constant rate of change. And in this case, we have, let's see, $70 to 5. So for this costs us $70 per 5 hours that they work at a job here. And if you notice, it's consistent as this goes up. Does this go up 70? Yes. Does it go up 5 over here? Yes. Goes up 5, goes up 70. So it has a consistent rate of change, and let's go ahead and simplify this as most we can to find its constant rate of change. So if we divide 70 by 5, we get $14 per 1 hour. All right, so it has a constant rate of change of $14 per hour. And the question asks, is this linear? Well, first of all, to know what linear means a straight line. Linear means line, means a straight line. So if something is increasing or decreasing at a constant rate, it never changes, it's said to be linear. So this is always linear. It's increasing at $14 per hour, or in this case, $70 per 5 hours. It is doing that same thing throughout the entire set that we're given here anyway. So we would assume that the rest, if I work 25 hours, we would assume, since it's linear, that I would make $70 more, $350. Okay? So that's what linear means, and that's how we find the constant rate of change. So it says, example 2, find a constant rate of change for the amount of water in the swimming pool each hour as it's being filled. So they give us a couple points here in which the line goes through. And if we were to write this in an ordered pair, we'd have 2 as the x value and 500 as the y value. And in this case, it have 5 as the x value and let's see, 1250 as the y value. Or we could have written this in a table. After 2 hours, we have 500 gallons, and after 5 hours, we have 1,250 gallons. We could write this in a table, and we could do it the exact same as we did our other table. Okay, or our other thing. We got to find the difference in this, so we subtract 1,250 minus 500, and since we went 1,250 minus 500, we have to go 5 minus 2. Okay, so 1,250 minus 500 is 750, and 5 minus 2 is 3. So it's filling 750 gallons per 3 hours. So every 3 hours is filling it up 750 gallons. Well, let's simplify this. 3 goes into 750 because if you add up the digits, it adds up to be 12. So if we simplify, we take a 3 out of both these, it is filling up at 250 gallons per 1 hour. And it says interpret this graph's meaning. Well, it means exactly what we just said, that the swimming pool is filling up at a rate of 250 gallons per 1 hour. Okay, and it's consistently doing that. All right. The last one it's talking about is a proportional relationship. It says use a graph to determine if there is a proportional or linear relationship between the number of days a car is rented and the total charge. Explain your reasoning. Okay. Well, first off, let's see if it's linear. If it's linear, it's got to increase by the same rate. So from these 2 points, let's figure out what our rate of change is. All right, and again, we have a table for 1 day. It's going to cost us $40 to rent it. For 4 days, it's going to cost us $100 to rent it. And for 6 days, it's going to cost us $140 to rent it. Okay? So this being the case, to find its rate of change, let's go ahead and let's subtract the y values and the x values. So we're going to subtract 100 minus 40, and we're going to subtract 4 minus 1, and we get 60 all over 3, or $20 per 1 day. And let's see if that's the case in between here. If it continues that pattern, we would go 140 minus 100 and 6 minus 4. So we would get 40 all over 2, which would be $20 per 1 day. So it definitely is linear. It goes up at a consistent rate, $20 per day. Now let's see if it's proportional. If it's proportional, these ratios are going to have to be the same. So we're going to pay $40 for 1 day, or we could pay, since it's going up by 20s, $60 for 2 days, or we could pay $80 for 3 days, or we could pay $100 for 4 days. Is this proportional is what it's asking. So does this fraction equal this fraction? Does this fraction equal that fraction? That's what proportional means. Whether ratios equal each other, that's a proportion. So in this case, 40 over 1 is reduced. Well, let's reduce this guy. It would be 30 all over 1. Well, we already know that that's not the case. That is not true. So this is not proportional. However, it is linear. It increases at the same rate, but it is not proportional. Hope this helps. We'll see you in class.